It's no medium. Hello everyone, it's November the 7th. We have a medium question today. Number 43. I must have done it before. Many times. Oh wow, back in 2018. That's when I was trying different things. I started Python, and then CPP, and then Java, Jesus, and across 3 different days. All right. Oh, multiply. Oh, given two non-negative integers represented as strings, return the product also represented as string. Must not use any built-in big integer library or convert the inputs to integer directly. Yeah, let's do it in the right way. I believe when I first did this, the reason I use Python is because I use just int, right? Inted, but that's what they wanted you to do. Digits only. Both do not contain any leading zero except the number 0 itself. So, and we cannot use built-in big integer. Basically, they want you to do the multiplication by itself. That makes it difficult. How do you do multiplication? Like, let's say 123 times 4, 5, 6. So you can do 123 times 6. That we can do. Do we need big? We don't need big int for this. This we can just, right? And then we can do basically as a result of 120. Basically, we're gonna do 123 times 400 plus 123 times 500 plus 123 times 6. This is what we're gonna do, and each one we can. So after we compute, then we need to do more than just multiplication. We also need to do addition, right? We need to do addition. So every value needs to be represented as an array, and so we can do this 200 array, right? So 200 array, and we can do 123. Yeah, it's going to be this value. Return that into an array with all numbers, multiply by the single value, right? Single value, single value, single value. And after the single value, we just append however many zeros we need to append. And then we do plus, right? We do plus. We can do plus. So I think a good way of handling this, we need some, how should I call it? We need some, ways to handle it. Let me see. If we have 200 to start with, well, I mean, it depends on, let me think. We just have 200, right? We don't even worry. We just have 200, and then we fill in the value. So the first value we can fill in, which is easy to fill in. We're just going back to the front, we fill in, and that will be the first value. And then for this one, for each one, we can compute a new representation, which is fine, a new representation, and then we just, the starting position will be different. And then once we get it, we will have to sum them up, right? Sum them up. How do we sum them up? We can write a sum. Let's start with a 0, and then we just sum. Okay, that's a plan. That is a plan. Let's see. Yeah, this is not difficult in terms of the logic, but it is a little bit challenging in terms of implementation. And because I don't want to, just handle, say, how large the thing needs to be, so I'm just gonna. Oh, I just realized num1, num2 is 200, so the multiplication could be longer. So actually, I don't know how long it's gonna be. That is interesting. Well, what we can do is we use number 1, right? Because if we do number 1 multiplied by a single value, the most it will happen, right, is we just add another 0, right? And then we just, yeah, that might be a better idea. And we return as a string, which is, that's easy to do. So what we're gonna do is we're gonna have a couple of functions, right? So we're gonna have a function called add, which will take a num1 list, right? When this become a list of integer, and num2 list of integer, and we're gonna return a new list of integer, right? So we have num1 and num2, so we can just add from the back to the front, right, until one of them is exhausted. Until one of them exhausted. Till one of them exhausted. Yeah, we can do that. So we're gonna have item j, right, and then we're gonna add them together. We have a carry, and we'll keep going until one of them exhausts, and then we have a carry. Then we see which one exhausts. Or that's hard to do. And 200 times 200 will be like 4. No, that's too long. We don't need that. So we'll exhaust. Then we see which one exhausts first, right? And then we will continue adding new things. Yeah, that's fine. So what we're gonna say is we can reverse them. We can reverse at the end. So we're gonna say result is gonna be this, right? And we say ij both equals to ij both equals to, so I will be equal to len, right? We're gonna go num1 list minus 1. J is length num2 minus 1, right? So the goal is while I smaller than 0, while I smaller equal to 0, and j smaller equal to 0, right? And then we're going to have a carry and start with 0. And then we're going to say res, so we're going to say s is equal to num1 list I plus num2 list j, right? So adding together is s. And then we're going to say, s is added together plus carry. Once we do that, we're going to say r and carry will equal to div mod s and 10, right? So I think if you get this wrong, it should be carry is here, remaining is here, right? So carry, I mean, we can just get it to 0, so we can just do res minus 1, right? Res minus 1 will be the remainder, and c will be the carry. So carry and this equals that, and then after we're done, we're gonna say I don't like it. I want the rest to, I want like ones that we can do, right? Ones we can do, so we know rest we just append a 0, right? And then we do this, right? And then I minus equal 1, j minus equal 1, and then we go back, and if it's still good, add a new one, and then they add plus this, right? So once it's coming out, which means one of them has ended. Say if I is smaller than 0, right? So we say if I is smaller than 0, then while j is smaller or equal to 0. No, why is smaller equal to? Come on, this is large equal to. Jeez, that's large equal to, and this is large equal to. So while this large equal to 0, again, same thing. We say res.append a 0, right? And then s equals to, that's going to be num2 list j plus the carry, right? And then carry res minus 1 will equal to div mod s and 10, and then we're going to keep going until we exhaust. And then we say j minus equal 1, right, until we exhaust. Else, so I is still larger equal to 0, then we do the I, right? So we do here, so we do I, and then it's going to num1, because I, C res, this is all fine, and I minus equal 0, right? Until they all done. And then we're going to return res, we just reverse it. So that's to add. Now we need to also say multiply, right? So def mult single value, mult 1-digit value. How do I say mult 1 digit, right? So we have a num list, which is a list of integers, and then we have a 1-digit, it's an int, and this will return a list of int. So how do we do this? Well, we have a res, right? And then it's going to be for I in range, so len num list minus 1, minus 1, minus 1, right? So what do? We say res.append, that is append of 0, and then we're going to do carry as 0, and do product, right, equals num list I times 1 digit. So time 1 digits, we need to div mod. So div mod this with 10, and then we're going to get a carry, and then the remaining. All right, and then we say, oh, this ain't just minus 1, right? That's the remaining. That's the remaining. Remaining goes to there, and we're going to have a carry. Oh, hold on. That's not true. That will be product. Nope, we need a product. So product equals to, yeah, don't be so fast. So we need a product first, right? So we need a product, and then we need the product plus the carry, right? So it's going to be carry carry, this will be the product plus a carry plus, it's the same, so we can just do carry here, right? So P is this, and then we div mod, get a new, and keep going until we get out. Oh, what if we have a carry at the end, right? So the last one, s equals this, carry. So let's say if carry, then res.append carry. Same thing here. Once we get out, if carry, res.append carry. Then return res, go this way. Okay. So now we have two functions that we can use. And we're going to do num1 list equals to int int n, right? Let's say for n in num1 and num2 equals int n for n in num2, right? So we get an integer array for these two, and then what? And then what we have is so res equals to 0, right? And then we're gonna say for we need to know how many more zeros to add. How do we know? If we go on the front, let's just say for I, number enumerate num2 list, right? So I is the integer, I is the index, and then we can use a length, right? The length of num2. The length of num2 minus the int. So if let's say if this is 3, right? Minus 0 is 3, so minus 1 would be the how many zeros we need to add. Okay, so in that case, we're gonna have product for equal to self dot mult one integer. So I'm gonna say num1 list and then multiply by n, right? And after that, p will be this plus 0 times len num2 list minus I minus 1. So that we add a bunch of zeros to the end. And after that, res equals to self dot add res and p, right? Which we don't need p. We can simply do something like this. So we're gonna add this and this, and we can just say n2 will equal to len num2. So let's just simplify this as n2. Right, so res equals this, and now finally I'm going to return. So I'm going to return str n for n in res. I'm going to join this. Join. This has to be this. Okay. Now let's test this. Well, we can have many test cases. Actually, for this use, we can use random number test cases, but it's fine. We can just no. It'll be fun to write a test case ourselves. So we'll say from random import to randint, right? And the tests will just be let's say num test. Let's do num test is 10, and let's do num digit. All right, num digit. Let's start with 3 digits. Okay, and the test will be this, right? And for this in range num test, and then each one is going to be is going to be 2 values. Right? We have 2 values, so we're going to have this 2 values, and the first value we're going to say randint something. Second value will be randint something, right? And then the first value is going to be digit, so it's going to be 10 to the num digit to 10 to the num, right, num digit plus 1 and minus 1, right? So that is the first. Actually, for both of them is this. All right, that's a test. So we can just do for I, this is going to be num1, this is going to be num2, and before we pass it in, we have to turn them into str. So res equals to this multiply, right? No, not this one. Multiply. Let's say str num1 and str num2. And then we say if res equals to str num1 times num2, then pass. Otherwise, we're going to say fail. There's no answer. All right, we probably need answer. So answer equals to this. Okay, it's answer here. Answer result, and test. And the test is going to be num1. Let's do this num1 and num2. Run it. All pass for 3 digits. Okay. How about we go for 4 digits? Okay, 5 digits. 100 digits. Oh wow. Okay, so 200 digits. Okay, so I think this 1 digit. Okay. I think we pass everything. How about changing digits? So let's say num1 digit, right, and num2 digit. Right, that would be more fun. Let's say num2 digit and num1 digit is this, right? So I'm say num1 digit and this num2 digits. Oh, both have to change. All right, so now we have different digits. Still pass. So yeah, I think this is solid. All right, come in here. We just submit. I got a wrong answer. Oh, holy moly, it's 0. Oh, 0 is never. Oh man. So, we have to remove the leading zeros. Huh. 1 digit. I have a. Wait, 0 is. 0 is never random to 0? That is bonkers. Oh, 10 to the 1. Oh, I never get to the. Oh, I need to get to 0. But still, 0 is not part of it. Ah, this test is not complete. Yeah, it has to be 0. Yeah, number of digits. Jeez. Number of digits. Oh, I need to redo this. How to include? So number of digits is this. This actually has to be -1. Right? This actually has to be -1 because 1 digit is and this is just times. That's 10. Right? 2 digits. Ah, it was my bad. That wasn't right. Doing this right. But still, we are not including zeros. Right? 0 is not included. Some syntax error. And 10 to this, and 10 to this. I think we need another one. Nope. Oh no, wait. I'm missing here. Now I have too many. Wait, what the heck? Random. Oh, we do need another one. Yeah. But that's the issue. So this digit is 1, but we need to include 0, so it has to be -1. There we go. Now we have 0 included. Now you see it's wrong. Okay, so 0 is the only issue. So how do we handle 0? Well, we have the result, right? And we just need to So you can say res str will equal to this, and we can strip dot left strip 0, right? This will remove all the 0 on the left, and then we return res, but that will still be wrong because str has no attribute for the strip, right? That will be this. There we go. So we can return this if res, right? Else 0. There you go. That is how we solve it. So basically, have to, yeah, it's the test case. The test case was not strong enough earlier. So this shall be right. There we go. 276, about the same, right? About the same. Let's see what I did in the past. I have two results that I might be taking a look. Multiply. I mean, honestly, this looks shorter. I have 2 carries. Times it and do this and yeah, I mean, that is left strip, that's the same. So the very difference between these solutions, the previous solutions, it is like shorter, right? You feel like these are shorter, but okay, we handle, yeah, that's actually a good way to handle, so you don't have to go through all that. I'm gonna implement this so we can make it simpler. We don't have to left strip. So basically just say if nums1, if num1 equal to 0, right, or num2 equal to 0, then we immediately return 0. Right, so we don't have to go through this. We simply turn this. That's the end of the story. And then we can just run, and then all work. And then max digits. Wow, I do have max digits. And the answer is this. And then for B, carry, and then for A, temp is okay, it's int. Answer AIBI plus 1. I see what I was doing. So AIBI plus 1 is the current answer. So we go back to the front, right? So AI plus BI. So, wait, is this the carry? No. That's the previous result. It's previous result. So if that's going to be this, I want to do these two multiply. And we need to add to the previous. Hold on, let me think. So for 1, 2, 3, 4, 5, 6. So this times this, and then start with answer is 0. Length. It always exists. Oh, that will be 0. And if we do this and this, hold up. Okay, let's do this. So if these two multiply, I need to add to this value. How do I find this value? This value is this is a 0, 1, 2, right? So 2 plus 1 minus a plus 1. Huh? Well, because I set it, so for every AIBI, I set the result to this value. Okay, so that's the same position, right? So that's the same position. AI plus BI. So we go all the way to the right. Oh, AI plus BI plus 1. That is the last position if we're going from the last one. And every time we do it, and then we go to new one, new AI and BI, and then, oh, I see, because the second position on the A and the third position on the B, right, their result is in the same position as third position on A and the second position on B. So we can put them at the same position. That's why I grab it from here, and then let's see. So this could be div mod, right? This is div mod, and then once we've done everything, wait, what is this? Extra digit. If C1, C2 is not 0. There's no C1, there's no C2. So basically, I multiply all the A, right, at the end. And when we get out, A will be 0. Right? When we get out, A will be 0. And the 1 before it, that's going to be BI. That's the extra carry. So we add the extra carry. Makes sense. Makes sense. And then so it's different idea, right? This one, I basically break down the problem into two parts, and then I write a helper function for each part. I have helper function for them. So overall, it's quite straightforward. So LeetCode what? This is 43, right? LeetCode 43. Use two helper functions to handle simple operations. Add two numbers with represented by a list of integers, and multiply one list of integers with one digit number. Combining these two helper functions, we can find the product of num1 and num2 easily. However, compared to solution 2, this one feels a bit too cumbersome. That said, I think this solution is more intuitive and easier to debug. So this one runs in OMN, right? OMN, and what time we got? We got 276, right? 276 seconds, or 10%. Thank you. All right, so let's try the other one. Right, I can try the other one. Let me just copy and paste this. Okay. Let's try that out ourselves. So this is the, I think this probably is the official. Solution 2. This is most likely. Let's just take a look if it's official. elementary math. Yeah, I'm pretty sure this is the official solution. Or pair of digits. Yeah, I think this is the one. Yeah. Why? This could be an interview question. That's a pretty good question. This is the more succinct that performs multiplication directly, right? Directly. It is from the official solution. So same thing. We're gonna handle this one first. Well, actually, we're gonna handle all of these at the beginning, right? And then for I in range, we say len num. Yeah, I'll do num1. -1, -1, -1, right? Oh, and we need a result. So result will equal to 0 times len num1 list plus len num2 list. Right, so that's I, and then for j in range, len num2 -1, -1, -1, right? So now we can do carry. You probably have a carry is this. Right, carries in the front. So now what we're gonna do is the carry plus, so the product. Right, the product is going to be num1 list I times num2 list j. Right. So the multiplication, and then we need to add res I plus j plus 1. So that is the key. So the key is the insight. The key is the insight that the temp result from multiplying ith digit from num1 and jth digit from num2 is located at the same position as multiplying jth digit from num1 and ith digit from num2. Right. So by doing this, this allows us to save the temporary result, right? Save the temp result and in the same array as the final result. It also helps that we use the largest, right? This is the largest possible length, max length of answer, right? And then we're going to do this, and this is I plus j plus 1. If we start from len this minus 1, len this minus 1, so add them together is len minus 2, so we're going to plus 1. That's the actual len at the end. So we're going to plus c, right? So all of this, then we're going to do div mod this with 10. Once we do that, we're going to say c and res I plus j plus 1 will equal to div mod, right? Once we're done, we'll go back, blah, 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 blah. At the end, we're going to just say res, because at the end, when we go through the entire thing, right, when we go through the entire thing in here, we exhausted the j. So when we come up with something more, then it has to be I plus minus 1. So j is going to be minus 1 plus 1, so that's I. Res I plus equal to c, right? Because we have a carry, we have to add it to. So extra carry after multiplying. Wait, hold on. Do we also need to? No, we don't have to handle because the positioning representing the times 10 or not times 10. So extra carry after the current round of multiplication. So basically each round we are only multiplying like one value, right? So it's the same. So basically we say, oh, hold on, we're multiplying the second value to the first value actually, right? We're actually doing the second value multiplying each digits of the first value. That's why in my original it's ing is reversed. That's the second value multiplying the first value. This is the same, multiplying the first value. So we do this, blah, 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 and then we are going to, now because we have done this, so there are leading zeros. So I'm going to say res, but it will not be all zero. So we can actually return, we can return this and dot left strip all the zeros. So let's try solution 2. Why you always misspell this? I don't understand. Right? So this one is correct. I'll run a couple more. Let's do so we including 0, let's do like 100 and 100 digits. Yeah, so this is correct. So I'm gonna try it. Most likely it's correct. It should be because the test case is complete. Yeah, so this one's faster. So I don't have to go through all the. And this I do believe is still OMN. Yeah, it's OMN. So this is still OMN, but we have a bit lower overhead. It's actually twice as fast almost. Yeah, it is twice as fast. 53%. 2. Okay, so that shall be it for today. I actually do want to, yeah, I want to roll another one. Actually, not roll another one. I know what problem I want to do. We're handling single values for the past 2 days, so I want to keep this one going. It's probably maybe 200 something. Wait, what is the search? Single value, single number. I think it's called single number. Yeah, we have this one, 137. Try to see what's the difference. Yeah, we learned the trick. So we say, given an array where every element appears 3 times, except for 1, which appears exactly once, find the single element. Ooh. Alright, so if it's 3 times, does exclusive OR still work? Well, I mean, we can exclusive OR, but then it will be the exclusive OR result of everybody. 3 times. It appears 3 times. Jesus. 3 times. It feels like all the tricks learned previously didn't work. How do we handle 3 times? Oh my god. 3 times. If we're exclusive of everything, the result will be every value exclusive or everything. Let me think. If I exclusive or, let's say 2, 2, 3, 2, and exclusive or everything, the result is just 2 exclusive of 3, right? Now, if I do 2 exclusive of 3 and use that to exclusive or the original one, then we're going to give 0. We're going to have a 0. So that trick doesn't work. I thought it was going to work, but no. Okay. Man. What is the trick this time? It's like every time is a new trick. Exclusive or... yeah, everything appears once, and if exclusive or again, that's going to turn into 0 because now we doubled. Right? We add another new one to it, and then we add a new one to it, and also the singular value also get doubled. So that's not working. And the final value is every single value. Right? Every single value. Oh. No clue. No clue whatsoever. Why? This is my nemesis. I just can't do it. I cannot do it. What the heck? I've done the first one, so we learned it's exclusive OR. And then yesterday, I tried exclusive OR, it didn't work, and I see the answer. Oh, I know, that's the trick. We find the difference between the two. Right, but now, this time we have 3. We have 3. Appear 3 times. And exclusive OR will give us the result of everybody. Everybody exclusive OR. I mean, for everybody exclusive OR, that's not gonna make any difference. Let me think. So we have everybody the sum times 3 plus the singular value. It's called x, right? And then if we mod 3, what's going to happen if we mod 3? Well, mod 3 will equal to this value, mod 3. If it's 0, then we know the value is divisible by 3. If not, so no, it's not divisible. So we have a mod, right? So that we can shave off some time. But still, everybody exclusive OR. Wow, these are very challenging for me. Bit manipulation, I know. Similar question. I don't need similar questions, but this is going to be bit manipulation again. How do we bit manipulate this one? Right, what's 2? What's 2 and 3? Like 0, 1, right? 0, 1, 0, 1, 0, 1, 99. So event would be 0 exclusive or 1 exclusive or 99, right? And then we know everybody else exclusive or, and then our target. So everybody else exclusive or, we have some bit. And then me, if we keep looking, we have to find the first bit that's not the same. That means everybody else exclusive or. If we consider everybody else exclusive or as one value, right? All of them. So all of them, and they exclusive or will have a value which is different from me. I have, let's say I have 1, and they all have 0. But that doesn't mean that they are all 0. That just means, well, that does mean like we can, if there's a 0, then we remove all of them, right? If we remove, yeah, let's say the first bit that's different, right? First bit, that's a 1. The first bit, that's a 1. So that means either my value has a 1 and everybody else has a 0, or I have a 0 and everybody has a 1, right? So let's say everybody else, I don't know, everybody else could have a 1, have a 0. And then I can remove all of them and say I think I have a 1. And then the remaining would just be everybody else has 1, 1. And they're all in pairs. Right? They must be in pairs. So if I remove this 0 thing, if I remove this everybody else that is 0 in this position, if I remove everybody else that has 0 at this position, and the remaining will be everybody else with a 1, including me, and then those ones will be they'll become 0, right? Now we're still talking about threes and threes. No, I don't think that's the way. If I can add value to it, no idea. I'm gonna give up. This is wow. Three strikes on this. None of them I was able to. Holy guacamole! Peak. General handle all these questions. Bit manipulation. $32N. What do you get from this? Just reading the title. 3 int variable. Constant space. I don't know. Well, the numbers are within 32. So are we saying check every single time? Hold on. So we have these values. So we have exclusive OR. I know the exclusive OR, right? And then we check the last one. If it's 0, what does that mean? Does that give us any hint on what the actual value is? It does not. I mean, it could be 0, it could be 1. Well, let's suppose, right? Suppose it's 0. And then, like if, okay, again, think again. If the current bit is after exclusive OR, the current bit is 0, right? That means my value, the last bit, and everybody else has the same bit, right? And I can assume if my value is 1, then everybody else shall be 1 as well. That means everybody else has the last bit will be different. So if I'm 1, and I can remove all the zeros in the last bit, then I'll get all the 1s in the last one. And if I exclusive OR, it's 0, 0 exclusive 0, and 1, 1 exclusive OR. So they has to be exclusive OR of all of them need to be 1, because final is 0. So everybody has to be 1, and we know if 0 and 0 exclusive OR is 0. So the only way is for all the 1s to be exclusive 1. So when you check everything else, if exclusive OR is 1, if everybody else exclusive OR is 1, then that makes sense. So it could be 1. What if I'm actually 0? If I am actually 0, but I assume it's 1, then I remove 0, then everybody else, if 1, 1, 1, shall be 0. So if I remove all the zeros from the last bit and everybody else exclusive OR, well, you don't know everybody else exclusive OR. All you know is total exclusive OR, right? So if I say my last one is 1, so I know that the total is 0, right? So I assume my last one is 1. So I remove all the 0. Then everybody else exclusive OR shall give us a 0. If that's the truth, then I think my last one is 1. But if I am actually 0, which means everybody else is also 0, but I remove all the zeros, so everybody else is 1, and then they exclusive OR shall give us 0, right? But I assumed I am 1. I assumed I'm 1. Assume my last bit is 1. So I remove 0. Bit. If I remove 0, and all we have remaining is 1, 1, 1, 1, 1, 1, right? And it's going to be. Hold on. I feel like I'm there, but it's a little bit because as 3, right? It's in triples. So it's going to be just 1, 1, 1, 1, 1. And the last one will be, if I'm 0 and I eliminate myself, then it depends on how many values there are. And we can count how many values, right? So number of values is 3k plus 1. So if I remove, that should be 3k. So the number of values is 3k, but the k you don't know, right? You don't know the k. I don't know the k. I assume we're saying like if I assume, we're saying like exclusive OR everything give us 0. I say if I am 1, suppose I'm 1, then I say everybody else shout exclusive OR to 1 in the last bit. All right. Everybody else should be last bit 1. Then let's say if I remove all 0, then the remaining value exclusive OR shall give us 0 as well. That means this is going to be 1. But if I remove 0, right, if I remove 0, and everybody else give us a 1, but that's also possible. It can be any value. Right? If it can be 0 and everybody can be 0. No, I don't know. Thought about it. Let's see. Oh my god. That is long. That is super long. Oh my god. What's your PSP times? Find that single one. Number of ones in the array is that whenever the counting number of one reaches a certain value, say k, count returns to 0 and starts over. Unchanged. K counts. Yeah, that's way too long. Oh. A dot length. Ones and twos. Ones, twos. Exclusive OR. And, oh Jesus, what the heck is this? Alright, this one will require significant effort. Count each bit modulo 3. Alright, screw it. We're going for the kill. But I don't want to waste time, so I'm gonna end it here, and I have to go in for this. For this large article I'm trying to comprehend. All right, I'll end it here. See you guys tomorrow. Adios.